They're all good day. Today, after a long span of time, we are meeting again on the subject matter of explanation of TRS, the Tropical Revolving Storm series. Also, this is all about upon the understanding of its origination and as well as the avoiding action by the master to be taken in case the vessel is stuck and or coming in the closest proximity of a TRS. I had broadcast this on my LinkedIn and a lot of other social media about this particular subject matter that I will be broadcasting this in due course. I have received encouragingly loads of our candidates, my comrades, and our followers, and they have encouraged me to broadcast these series. Furthermore, as we speak, I would request you to please do like, subscribe my YouTube channel on Marine Quiz Solutions, as you would appreciate that I have already broadcast so many things in order to facilitate the mariner and also help them in case of any adversity. I also have two of my WhatsApp channels which are already full, and I get so many queries, so I do the things accordingly. When I get so many, uh, overwhelming responses from my followers. Therefore, we begin. The subject matter today is the Tropical Revolving Storm series on understanding its origination and the avoiding action by the master, part 1. This is part 1, and thereafter, the subsequent lectures of the series will be broadcast on another platform, which I will talk about it at the conclusion of this lecture. So, once again, good day to all of you. Please do like, subscribe our channel with the bell icon and put your comments in case you wish to need to know more. And this certainly would help you. As far as my credibility credentials are concerned, that I've been almost 4+ decades out at sea and more than 2 decades as a master in a commanding situation, where I have encountered many force majeure kind of situations. End of the day, besides the satellite navigation system and all the electronic navigation system, the practical navigation, practical knowledge of the seamanship does prevail, which I've been talking about all this while right from the beginning of my channel, and uh, the, all the time when I'm even doing the mentoring and the assessment of the candidates concerned. Thank you. Thanks for your time. So, first we talk about the storm. I have basically made my own formulation to describe the storm, which may perhaps ring a bell in all of you. STORM. How I have nomenclatured is the storm in an abbreviation, that is storm into an expansion, is S for stop, and this is actually for the masters. What they would do not to succumb under any pressure or as far as the commercial obligations are concerned. S for stop, T for think, O for organize, R for review, and M for maneuver. So idea is that in case you come across a TRS in the vicinity about 300 odd nautical miles, which is a safe distance. But for some XYZ reason, if you come into the closest proximity, then what the master of the vessel should do. So S for stop. Stop doesn't mean to stop the ship, means take a step back. T for think. Think what is the next plan of action. O for organize. After you've assimilated all the reports, weather reports, speed, SPOS, SATC, satellite navigation system, or any other means, the weather facts, whatever you may have. So, stop. Stop means take a step back, think and organize yourself, assimilate all the information, and R for review, that what would be the most appropriate action for the master of the vessel to take to excuse me, maneuver the vessel out of the TRS. And after you have reviewed, then the master of the vessel knows how and where to maneuver the vessel to keep clear of the TRS or the tropical revolving storm. As far as the safety of navigation is concerned, and in cognizance with the industrial practices, it is required to stay at least minimum 300 nautical miles away from the TRS storm. So, this lecture, I'll read the slide. This lecture is also based upon the practical knowledge of the self and the seamanship in cognizance with the principles of the subject matter, that is, to save the lives at sea. Now, as we go on, we will talk about initially in this particular lecture, that is DRS Part 1, the initial origination and the basics of how does it originate. And this will help lots of candidates for their written, maybe as well as their oral examination. So taking that purview into account, I am broadcasting this series. I hope you would appreciate and like it. Thank you. So, a tropical revolving storm or a TRS is a storm system which, with a low pressure at the center, around which the winds gust to a gale force 34 knots or to a force 8 or more, and blows spirally inwards anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Now, whatever I read, I'm trying to, or I will try to interpret the same thing into, simple language so the people can understand. A TRS is a low pressure origination where you have the eye of the storm in the center, and outside you have the contours of the wind force, which is reflected even in the weather report as far as the gradient is concerned. In case you find there's a low around your vicinity which has a very steep gradient. In other words, the low is the anti-clockwise circles as concentric circles are very close. That means the wind force will be very strong. If they are widely open, that means the wind force will be less. The opposite takes place in the southern hemisphere. That's what I've described. At this point in time, you must also check your barometer in case of in an hour, if you find the barometric pressure or the barometric tendency is dropping gradually, there's a steep gradient, and or in your 4 hours of bridge watch, if you find the barometric tendency has dropped to more than 2 millibars, the duty officer shall intimate and inform the master immediately. That means you may be heading towards a not very favorable weather. Now, as we speak, the nomenclature of the TRS, which is in a common various places in the world, but its terminology varies geographically. It is called or nomenclature as cyclone in the Bay of Bengal and Arabian Sea, hurricane, and it's used. This nomenclature is used in the western side of the North Atlantic and South Pacific. Cordonnazo is used in the eastern side of the North Pacific. Typhoon is used in the western side of the North Pacific. Willy Willy is used in the eastern side of the South Indian Ocean. So, don't go on the nomenclature. This I'm talking about from the practicality point of view. Look at the other aspects, the other variants or other parameters what you received much you receive a weather report, be it on SATC, or if you have a program named SPOS or any other program which will basically give you all the indications along with its movement. So I'm starting this particular thing from the basics, the nomenclature of the TRS, what it is called in different places or different parts of the world. I have already narrated that. Next slide, when we go to it, is the origination of a TRS and its climatology. Now, these 6 points are very important, which basically describes the origination of the storm, what all are the congenial surroundings or the things or the atmospheric conditions and the weather conditions and climatology which are required in an ambient condition for a TRS or a storm to develop. Number one, warm front over 27 degrees centigrade, that is, the moist air rises from the surface of sea. As it rises, it meets the cooler air and condenses to formulate into clouds and rain. Point number three, this condensation releases huge amount of energy and culminates into strong winds. Point number four, the winds are thereby driven by the Earth's rotation and the Coriolis forces. Number five, due to the Earth's rotation and revolution, winds are sucked violently upward in the form of a vortex, which can be approximately up to 1,000 kilometers or up to 5 to 600 nautical miles approximately wide. The wind speeds can get as high as 200 nautical miles per hour. Point number six, the storms are fueled by damp air. However, when they reach the landmass, the dry air gets sucked into a diurnal variation and the energy dissipates gradually as they make the landmass inwards. Now, to explain you in the crux of matter in a layman's terminology, that the warm front of the warm air being less denser will lie low, and the moist air rises from the surface over the sea. So when the parcel of the air which is warm and cold, they meet together because of the atmospheric condition, they come into a kind of a circulation. That's what it means. Right now, what I'm explaining you is the basics, which may help the third mate or second mate, maybe a mate candidate, but I will step the things upward or graduate it step by step so that you will understand what I'm trying to say. So for the time being, you must realize that anything which is lighter will be lying low and which is denser, and the thing which is lighter, this is basically physics, will be rising above. As it rises, it meets the cooler air, all those things I've described. So the cooler air it meets and it basically comes into a kind of a circulation. And the winds are also driven by the Earth's rotation and the revolution as well as the Coriolis forces. As we know, the Coriolis forces in the northern hemisphere deflect the storms to the right in the northern hemisphere and to the left in the southern hemisphere. And remaining other things, as we speak, we'll talk about it. And as you must have noticed that during the storm of even it has many times made a landfall to the Indian coast as well. But when they come to the landfall or make a landfall to the coast, the energy is dissipated. At sea or in ocean, the energy is gained from the climatology, which what I've described earlier. The origin, movement, and the lifespan. The TRS originates in latitude between 5 to 20 degrees and travels between west to west northwest in northern hemisphere and between west to west southwest in the southern hemisphere. At a speed of approximately about 12 knots, somewhere along their track, they recurve away from the equator and curve to north and then curve to northeast in the northern hemisphere. And they, respectively in the southern hemisphere, they curve south and then they curve to southeast in the southern hemisphere, which I will show you in the pictorial diagram, and you will see for yourself. That will be in the next slide. Track, the route over which the TRS is already passed. Path, the predicted route over which there is a possibility of the TRS passing at near future. Another point on route is called vertex, which is the westmost point of the TRS when recurving takes place. Now, when I show you this in the pictorial thing, you will understand all these definitions, and I'll explain you accordingly. So, if there is a storm which is originated in the northern hemisphere, it will go to west, west northwest, and it will recurve to the northeast in the northern hemisphere, what I spoke. And this is the vortex which was talked about. This is the track, and this is the path which I explained in the previous slide. Now, why the storm is turning to right in the northern hemisphere is because of the Coriolis forces. In the southern hemisphere, the same thing, but it is going to deflect the storm to the left in other words, initially it will go to west, southwest, and then it will go to southeast. That is because of the Coriolis forces. So, but also remember, between equator 0 degree latitude to about 5 to 10 degrees, we have also ITCZ, that is Intertropical Convergence Zone. Because when the earth rotates, as we know, because of the rotation and revolution, the earth is actually oblated at poles, and because of this oblation, the Coriolis forces they develop and they act accordingly, as I've shown you in this particular slide. Now, coming to the life cycle of the TRS. The average lifespan of a TRS is approximately 9 days. However, it can vary from 2 to 3 days or maybe 20 days, subject to the favorable conditions and energy gained by the subject TRS. In case there is no landmass, the TRS can actually play havoc and can extend as far as its life cycle is concerned. Formulation. The formulation of a TRS is dependent upon the 6 favorable environmental conditions as described earlier, which I had shown you in my previous slide, which are available in the ITCZ. That's what I'm talking about. So, the 6 conditions which I described are here. That is what I was talking about in my, the slide which I've shown you currently. I go back to the same slide. These are the 6 conditions. So, the tropical cyclones, now let's talk about their characteristics. The TRS gains energy from the latent heat driven by a significant thunderstorm activity and condensation of moisture. In other words, the TRS formulation can be called as a gigantic vertical heat engine. So the amount of heat, the amount of energy which it produces is tremendous, maybe horrendous, which is also powered by the Earth's gravitational force and its rotation as well, what I spoke to you all a bit earlier. On satellite images, this stage appears to as unusually active but poorly organized area of convection thunderstorms sometimes skirt cumulus clouds bends towards an active area of thunderstorms, which indicates the location of the center. At this stage, if the TRS moves inland, they make a little or no damage, but they may also form heavy air, heavy rain and flooding of the areas, that is the torrential rains. Of lately, what I recall, I think few months back, the storm had touched the southern part of Indian coast. For some reason, it was getting energy even after it, gained. It had touched the landfall, maybe because of the inland waters. It further gained the energy and created havoc. I think it was in Madras, probably eastern coast of India. This is one of the example I'm giving you. And torrential rains I've experienced many times. This is normally in the belt between 0 to 15 to 20 degrees latitude, where the countries are, where the wind gusts all of a sudden up to maybe 100 knots. I have experienced that when I was at anchor in Thailand and I had to pick up the anchor immediately. Trust me, it was very difficult, but I managed to pick up the anchor because it gives you no absolutely warning. The next thing, around the oceanic high, which is situated about 30 degrees north and 30 degrees south in the middle of large oceans. After recurving, the speed of the travel increases. That is, in the northern hemisphere, the storm recurves to right, southern it recurves to left. It gains the speed. Excuse me, I've got a little throat problem today. After recovering, the speed of the travel increases to about 15 to 20 knots. Sometimes the TRS after this point does not curve or recurve at all, but continues on its original path, crosses the coast and dissipates quickly thereafter due to friction and the lack of moisture. Now, one thing you must appreciate because of so many things which are happening globally. Main thing is being global warming. Lots of things have basically started playing, in a gymnastic manner. Kind of summer solstice goes upside down. So there have been cases, and as far as I'm concerned, I've been through in my 23 years of command experience, experienced lots of horrendous things like this. But ultimately, it's like the interface of man and machine which matters. Provided you have the knowledge, you have a situational awareness, and the know-how as well. Now, coming to the next point, it is important to note that all the TRS do not follow such definite paths and speeds in the initial stages. Occasionally, storms have remained practically stationary or made small loops for as long as 4 days. Sometimes, the storms you may find they behave very erratically, maybe because of the global warming and lots of other factors, and they stay at one location 3 to 4 days. What I recall practically, I've seen that sort of situation at least for 24 to 48 hours where the storm was almost stationary and I was passing more than 300 nautical miles, and suddenly I found that she has recurved and coming right in front of me. So there have been lots of cases, and that's what I talk about when I talk, define storm. That is, going back to the initial slide, that is stop, think, organize yourself, review, and maneuver. So you need to basically take your call, this is especially for the masters, that stop, think, organize yourself, and then maneuver accordingly. Because this has, the element of the not only the safety of navigation but the safety of life as well. And as we speak, safety of life takes precedence over and above each and everything. Okay. Now the semicircles, if a storm is divided along the route at which the storm is passing, we get two parts which are right-hand semicircle or RHSC. It is the half of the storm which lies to the right of the observer who faces along the route of the storm. For a stationary observer, here the wind veers steadily. These are the characteristics of the RHS. Left-hand semicircle, it is the half of the storm which lies to the left of the observer who faces along the route of the storm. For a stationary observer, here the wind backs steadily. If you remember the slide, what I'd shown you, this one. So, you see the storm here, TRS, and the right hand and the left hand semicircle, which has been highlighted over here. As and how I proceed, and with your doubts, with your comments, with your subscriptions, I will keep on alleviating this particular lecture more and more. Now, last but not the least, this is first and foremost the end of the TRS series part 1. I am going to describe all this thing in short and nutshell manner so that I believe the people want, small videos. So I'm giving you what you guys want. Thereafter, please log on to this site app, that is School, SKOOL, and register for the next follow-up lectures on the TRS. The TRS series part 2, and thereafter all the follow-up will be announced on the LinkedIn as well as on the app respectively. The app means the school app. For you all to log on to this app, this is the link. You please click on to the link or copy and paste on the Google. You reach there. You need to register, and that's where you will see me again. And if I get loads of response, then I will also do the live streaming of this series where we are one to one, and I will answer all your questions and queries. Also, last but not the least, as you know, the origination, I've been working for last 2.5 years. I'm still a mooring master and an active master. But to facilitate and help the mariners worldwide, I have been broadcasting loads of things on this on my channel. And as we speak today, I'm also I'm qualified journalist as well. So I would ask you and request you to please like, subscribe, along with the bell icon on my YouTube channel, Marine Quest Solutions. Thank you, ladies and gentlemen, for your time. And thanks for listening to me. I'll be there to help you out whenever you need me. But please do like, subscribe. But also remember that thereafter, all the series, remaining part of the series of the TRS will be broadcast on School. And you need to carry out the registration. And this is the link for the registration. Please do the needful. Thank you.